right, hopefully you took my advice and you're doing worksheet 5 before you're doing worksheet 4. I will probably change the order of that later. But for worksheet 5, what we're going to do is we're going to look at which of these methods that we've learned are the best to use for each type of systems of equations. Now, we can always, and hopefully you've gotten this point by now, we can always use the calculator if we have them both in slope-intercept form. If both of the equations are in slope-intercept form, which means that we have something like y equals 2x minus 3 and y equals negative 3x plus 4, where we have y equals something and y equals something, slope-intercept form. If we have it in slope-intercept form, we have our most options. We can graph it easily. We can set them equal to each other because I know that that is y, so I can set that equal. I can go negative 3x plus 4 equals 2x minus 3. So I can use that method if I like. That is a form of substitution, so I am just substituting. Linear combination or elimination is that method where we add them together. In this case, that wouldn't do us any good, so we wouldn't use that. We can plug this into the y equals on the calculator and just look on the graph, or look in the table and find out where they intersect. So when we have them in y equals, we have the most options, and we can use the calculator in both cases. So you can always change any one of them into y equals to be able to do that. If both equations are in standard form, we really only have one choice other than to change them into y equals. So standard form would be something like 2x minus 3y equals 12 and negative 2x plus 4y equals 13. We can't graph this easily, so we wouldn't use graphing. We can't set them equal to each other because we don't know, pardon me, this should be a y. We don't really know what to set equal to each other. Substitution doesn't work because it's not solved for anything. We can really only use linear combination. We can't graph it on the calculator because calculators don't graph in standard form. And we can't solve it on the table because, again, the calculators don't work that way. We have to put it in y equals. So to use y equals or to use any of the other methods, we would have to solve both of these for y. In this case, we don't want to do that. We want to do elimination or combination. So we would add this. And I'm not going to solve it all right now, but just to remind you what I'm talking about. And those are opposite. So we'd end up with y equals 25, and then we'd be able to solve for x. So we would be using combination. All right, so those are the two main things we've been doing, but let's look at some of the other possibilities. So one equation is in standard form, 2x minus 2y equals 5, and the other equation is in slope-intercept form. So y equals 2x plus 4. Okay, so in this case, again, remember, we could always solve for y equals and use any method we want. But if we didn't want to do that, what could we use here? We can't graph them because we can't graph this one easily. We can't set them equal to each other because they're not solved for the same thing. But we can use substitution because we know that y is equal to this. So we can take that and put it into there. So 2x minus 2 times whatever y is equals 5. And we can just plug that right into the calculator to find out what x is equal to, or we could solve it all out by hand. But we would use substitution, not linear combination, and not solving by graphing on the calculator or solving with the table on the calculator. So what if both equations are solved for x? So that would be like x equals 2y minus 3 and x equals y plus 4. Now in this case, we don't really know how to graph when it's equal to x. We only really know how to graph when it's equal to y. But we could set them equal to each other because they're both equal to x. So we would take that and put it where the x is. So y plus 4 equals 2y minus 3. And then we would be able to solve that for y. So we could set them equal to each other, which is a form of substitution. We wouldn't want to use linear combination because if we add these together, that doesn't really get us anywhere. We can't solve by graphing on the calculator unless we solve them both for y, and the same thing with the table. If one equation is in standard form, so that would be like 2x plus 3y equals 12, and the other one is solved for x, x equals 2y, easiest thing to do would be to substitute whatever x is, 2y for x. So we'd go 2 times whatever x is, and then do the rest of the equation. And you can solve that on the calculator or out by hand. So what we would want to use here is substitution. Can't really graph them because we don't know how to graph those two. Can't set them equal to each other, but we can use substitution. We wouldn't want to use linear combination because they're not in the same form. And again, we can't graph on the calculator or on the table on the calculator unless they're both in y equals, which we could do. We could set those up into y equals. All right, so the last one here. One equation is in slope-intercept form. So y equals 2x minus 3. And one equation is solved for x. X equals 2y, sorry. Solve for x. Okay, so on this one, again, we can't graph it because we don't really know how to graph these unless we solve it for y, which we could do. Set them equal to each other. There's really nothing to set equal to each other, but we can use substitution. So I'm going to take that, and I'm going to put it where the x is. And we get y equals 2 times whatever x is, which we know it's 2y minus 3. And then we would solve that one out. So substitution is the correct solution. Linear combination, they're not in the same form, so we don't want to do that. The x's and y's aren't in the same place. And again, we can't graph on the calculator or on the table on the calculator unless they're both in y equals. So unless you don't want to change things around, these would be the simplest methods to use to solve those.